students. Basically, we are discussing today normality. It's one of the concentration terms that allows us to find out the concentration of unknown solute in a given solution. Here goes the definition. It is defined as the number of gram equivalents. Students, you need to understand. We are taking number of gram equivalents of the solute dissolved per liter of the solution. Okay, in this particular definition, all eyes must be on the term called gram equivalents. Okay, so the gram equivalent of the solute can be defined or can be calculated by taking the given weight of the solute divided by its equivalent mass into concentration. Okay, now in the same equation we come across a term called equivalent mass. Equivalent mass can be calculated. Equivalent mass of any solute can be calculated like this. Okay, you can take molar mass of the solute divided by n factor into concentration, and this will help you to find out the equivalent mass. Okay, so whenever you want to find out the equivalent mass of any solute, you need to do one thing. Just take two factors into concentration, its molar mass and n factor. So basically, one more important term called n factor. What is this all about? As I have already written on the screen, that n factor depends upon the nature of the solute. Okay, if the nature of the solute is acidic, basic, or it is a salt, or it is an oxidizing or reducing agent, its n factor is going to depend drastically on the nature of the solute. Okay, so for now I'm not going to elaborate n factor. This could involve a different topic where I will be discussing n factor on length and how it is calculated for various types of solutes. Okay, so for now I'll be interested in putting the normality equation in the mathematical form. So we can say that normality is equal to gram equivalent divided by volume in liters, or for that matter we can put gram equivalents is equal to normality of the solution multiplied by its volume in liters. Okay, so also for that matter we can say that normality can be also written as given weight of the solute divided by its equivalent weight of the solute multiplied by volume into liters. So we are basically putting the gram equivalent equation into this normality equation. Okay, so we are taking the value of gram equivalent, okay, in this particular equation. Okay, this could be the equation first, or we can put it like this way, equation first. Okay, so sometimes if volume is taken into milliliters, now the equation could be that its given weight of solute divided by equivalent weight of solute multiplied by volume in milliliters. For that matter you need to multiply the whole equation with the factor 1000. Okay, so this could be the equation second. Okay, so this wraps up the possible number of equations that can help us to find out the normality of a given solution. Okay, so directly I'll move to the concept called dilution law. Okay, dilution law. Basically, what is dilution law? If I have a solution, I can put it like this way. If I have a solution and it has some number of gram equivalents of solute dissolved in it, so for that matter its normality must be n1 and its volume must be v1. Okay, and if I'm adding some water to it, okay, so dilution law is nothing, it's the addition of water. Now the next solution is going to be a little large in volume, and because you are adding water, now this could be the solution 1 and this could be the solution 2 after the addition of water. Okay, so for that matter the normality will change from n1 to n2 and its volume is going to change from v1 to v2. Okay, but during this whole course of time, you must be you must understand one important factor, one important point is that is the number of gram equivalents in both the solutions are same. Basically, you are you are doing what? You are just adding the water, you are raising the volume, but this is not going to change the number of gram equivalents of the solute that were initially present in the stock solution, in the original solution. Okay, so in this equation, number of gram equivalent of solution 1 is equal to number of gram equivalent of solution 2. Basically this will be the scenario. Okay, for, and we know number of gram equivalents, we have the equation, it's equal to n into v. So if we will put it like this way, that gram equivalent of the solute before the dilution, so we can write it must be equal to n1 v1 and it will be equal to n2 v2, and this wraps up the equation for the dilution, so we got the equation, we got the very magical equation called n1 v1 and n2 v2. This equation we can note it down. This equation, it will help us to prepare the solution of a desired normality. Wow, that is the important point. With this equation, we'll be able to prepare the solution of desired normality. Okay, very fast we are taking a question into consideration. We are taking a numerical problem that will be totally solved with this equation. That's called equation of dilution. Okay, so now we'll be discussing the problem. Okay, here is the problem. So basically we have this problem: how many milliliters of 10 normal HCl are required to prepare 250 ml of 2 normal HCl. We need to break this problem. We know we can say solution to this problem will be like this. We know this question totally depends upon the law of dilution. Okay, so we know basically n1 v1 is equal to n2 v2. We have this dilution law equation and we can apply it to the above question and solve it permanently. Okay, so I need to break it. How will I break it? I'll be signifying the values for each factor over here. Like if I say n1, it must be equal to 10. If I go for v1, it is not given, I think. Yes, I'll have to find v1. Okay, n1 is 10, v1 is not given basically. Okay, so we will have n2 equal to as the question clearly says, n2 is 2. Wow. Okay, and v2 is 250 ml. You need to add some water. Okay, you need to add some water to the existing solution so that its volume would be 250 ml. So basically we need to understand, we need to find out from what amount of volume this 250 ml was obtained. Okay, so we have the equation, for that matter. That n1 v1 is equal to n2 v2. Wow, now we need to find v1. For that matter, I can say that v1 is equal to n2 v2 divided by n1. As simple as that. Very simple mathematics. No need to panic. Okay, no need to panic, students. Okay, so v1 is equal to, we have the values, n2 is it's 2 and v2 is 250. As we have already we have already listed the contents of this solution of this particular problem. Okay, so we have n1 equal to 10, and very simple calculation, the answer is going to be 50. So you are raising the 50 ml solution, you are basically raising the 50 ml solution to 250 ml. By what? By adding water. By adding water. It's not going to change the number of gram equivalents of the solute. It is definitely going to change the normality for that matter. Okay, so basically what we had discussion about in this particular topic, we discussed the normality. We know the normality includes a very important term called gram equivalent of the solute, and for that particular matter, gram equivalent of any solute is equal to volume of the solute divided by gram equivalent mass, and equivalent mass is equal to molar mass divided by n factor. And then we discussed the what? We discussed the dilution law, and we discussed the problem that's based on dilution law. So I hope you understand the whole, you will be definitely able to understand this whole topic, and in the next topic we will discuss something more interesting. For now, thank you so much for your kind attention.